Welcome to Pre-Calculus 1. I hope you come introduce yourself in person very soon. It's really helpful for me to connect with all of you and helps me prepare helpful content throughout the quarter. Over the next several weeks, we'll be working through the concepts of inequalities, functions, graphing, and using your calculator. I will occasionally read the text from your accompanying handouts because some students will listen to the whole video as a refresher while working on dinner or doing another activity at the same time. It's important information, but if you've read it already, you're welcome to skip to the part of the video where I start working out examples. Let's get started with our first concept, inequalities. Our objectives for this section are identify inequalities and find the interval on which they exist, identify polynomial inequalities and find the interval on which they exist, identify rational inequalities and find the interval on which they exist. It's important to remember some problems in algebra lead to inequalities instead of equations. The differences are, instead of an equality with an equal symbol, we have one of the following symbols: less than or equal to, greater than, and greater than or equal to. The solution to a linear equation is a number, but the solution to a linear inequality is generally a set of numbers. Infinitely many numbers, and there are three ways of showing the solution to an inequality: set notation, interval notation, and graphs. To solve an inequality, you can add, subtract any number to, from both sides. Also, multiply, divide any positive number is allowed. If both sides are multiplied or divided by a negative number, the sign switches direction or flips directions. Also, if a is greater than 0 and b is greater than 0, then a is less than or equal to b, and we can then imply that 1 over a is greater than or equal to 1 over b. If a is less than or equal to b, and c is less than or equal to d, then a plus c is less than or equal to b plus d. You can substitute actual numbers into these inequalities to see that they actually work, especially if you're freaking out a little bit with the new symbols all of a sudden. So now let's review the rules for polynomial inequalities. To solve a polynomial inequality, 1, move all the terms to one side of the inequality and have 0 on the other side. 2, find the zeros or x-intercepts by solving p of x equals 0. 3, use the x-intercepts to divide the number line into intervals. At this step, you need to decide if the zeros are part of your solution set or not. If greater than or equal to or less than or equal to, zeros are included. Number 4, determine the sign of each factor in each interval by testing a value, then determine the sign of p of x. And 5, select the intervals from which the inequality is satisfied and write in interval notation. Next, we'll start working some examples.